There's always a fun part when you kick off a live stream where you're like, I have no idea. Is there anybody out there? But we're going to kick off in about 2 minutes. I'm going to be doing Advent of Code, and the idea is that every day, for those of you who've not seen Advent of Code, they release little programming puzzles every day until Christmas. And my plan is to every day I am going to pick up the latest puzzle and I'm going to solve it, and I'm going to live stream the solution for fun, and because it's interesting to share, and because, hey, it's not like any of us have plans, right? Not like we're going outside and doing stuff. But first I just want to check that this is streaming and working and see how much latency I've got on the stream here. I'm not a seasoned streamer, as you can probably tell. Assuming that there's ooh, no, that's not good. That's not good. Oh, there we go. So, am I live? Am I live? Let's have a look. Oh, this is very exciting. There, I'm live. Ooh, hello. Hey, Renee. Volume is a bit low. Rah. No, not that button. How can I be louder? I can. No, I'm as loud as I can be. I'm cranked way up at this end. You be louder. Or I can bellow. Ah. Hello, friends. Right, let's do this. So, Advent of Code 2020. Now, the way that I'm going to run this, the rules that I set for myself, I'm not allowed to look at it in advance, so I have no idea what I'm getting myself in for. So every day at 4 o'clock-ish, I'm going to open it up, I'm going to have a look, I'm going to solve it. Today we're starting from absolute scratch. So literally I've got nothing, no code, empty folders. So what have I got myself in for? Let's have a look. So Advent of Code 2020. Day 1, report repair. After saving Christmas 5 years in a row, you've decided to take a vacation at a nice resort on a tropical island. Surely Christmas will go on without you. The tropical island has its own currency and is entirely cash only. That doesn't sound COVID safe to me. The gold coins used there have a little picture of a starfish. The locals just call them stars. None of the currency exchanges seem to have heard of them, but somehow you'll need to find 50 of these coins by the time you arrive so you can pay the deposit on your room. To save your vacation, you need to get all 50 stars by December the 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day. The second puzzle unlocked when you complete the first. Okay. Each puzzle grants 1 star. Okay. Good luck. Before you leave, the elves in accounting need you to fix your expense report. Apparently something isn't quite adding up. Specifically, they need you to find the 2 entries that sum to 2020 and then multiply those 2 numbers together. For example, suppose your expense report contained the following, blah. In this list, the 2 entries that sum to, okay. Cool. So for those of you who've not done Advent of Code before, the way that they engineer it is everyone gets the same puzzle, but everyone gets different inputs. Hey, Dan, how's it going? My algorithm will work for you if you log up and you want to steal my code and run my code on your input, but you can't get to the next stage by using... So when I finish solving this and I get an answer, my answer will get me through to the next round, but my answer won't work for you because everyone has unique input. Let's identify myself via Twitter. Hello, Twitter. Yeah, authorized. That all looks fine. Thank you very much. Boom. Okay. Look at that. All right. So I need to find the 2 entries that sum to 2020. Now, like I said, I'm starting from absolute scratch here. I haven't got anything set up. I'm going to spin up an empty GitHub repository. Nope, that's... there we go. And I'm going to create a folder for each. New repository. Advent of Code 2020. It's generic username. Good afternoon, generic username. Nice to see you. How are you? Yep, that'll do nicely. Advent of Code 2020. There we go, because repetition's good. If I said it twice, it must be true. Yeah, we'll grab one of those. We'll add a git ignore for Visual Studio, because that's what I'm using. Choose a license. Yeah, MIT, because why not? Do what you like with it. Just tell them, don't pretend you invented it. You can sell it, you can copy it. If anyone wants to sell my Advent of Code code, you're very welcome to try. We'll make it public. Boom, create repository. I love this part. All right, we'll copy that. Let's fire up. I got a Windows terminal here. D projects, GitHub, git clone thing. There we go. Right, cd advent of code. Yep, that's good. Ignore license readme. Fine, right. So I'm going to do this from the start. I'm going to do it in C# and .NET Core or .NET or .NET Framework or whatever. I think .NET 5 is now either a thing or it's about to be a thing. And with .NET 5, there's no core or framework. There's just .NET 5. But I'm going to do it in .NET using C# command line console applications. So, since yes, there's no Rockstar, I might do a couple of them in Rockstar. Last year, I tried to do Advent of Code in Rockstar. And what happened was the first day I realized I was missing language features, so I spent about 6 hours extending the language syntax and then about 2 hours implementing the solution. And then day 2 I had the same problem. So with the first week of Advent of Code, Rockstar got arrays, it got string joining, it got multi-dimensional arrays, and it was literally like it was a full-time job, just extending the language syntax enough to be able to do it. But you never know. We might, if there's a couple of little, if it's like previous years, Advent of Code kind of splits into little standalone exercises and then like bigger ones that build on what you're doing. And if we get some little standalone ones, I might do some of those in Rockstar just for fun, just to see what we can do with it. I'm going to do today in .NET. Mainly because there's no risk at all of me ending up having to extend the .NET language specification because it's missing a feature. Right, let's do a... where are we? .NET, well, let's have a look at our input first. So if I go back over to my Advent of Code, get your puzzle input. Okay, that is just a big list of numbers. So what do we need to do? We need to find the two numbers in there that sum to 2020 and then multiply them together. So let's grab that and save that to... Actually, let's do this first. I'm going to go into a console. I'm going to do a .NET new console -o day 1. Going to go into day 1 and I'm just going to run it and make sure I get a hello world. Ooh, an update. No, thank you, not now. .NET run. Boom, and it should say hello world. Cool, there we go. So something that I quite often do with new projects is the first thing that I push back up to GitHub is just the, so add everything, git commit -m, and this is literally the command line that I ran to get from there to here. .NET new console -o day 1. Push. There you go. So if you can't make your own hello world, you can go and clone that, and you can steal my hello world instead. Right. Let's go into day 1, and we'll fire up Visual Studio Code. Yay! There we go. Oh, I've just done something very weird. What have I done? I've got OBS, the open broadcasting, running on the middle window, and it's quite easy to pick up pieces of that by mistake instead of pieces of whatever I'm supposed to be picking up. Okay, program.cs. That color scheme is going to look horrible on the stream. Let's pick something. Hey, EPS, EPS. Are you EPS short for something, or are you encapsulated PostScript? We may never know. I'm glad you've been enjoying it. That looks kind of friendly. So there we go. That looks nice. We can see the code there. We'll spin with that. If you need that bigger, just shout on the stream. I'll crank it up a little bit. So what do we got? Let's go into our Advent of Code. Let's find that. Right-click, save as. So where are we? GitHub, Advent of Code 2020, day 1. I'm going to save that as input.txt. Okay, so far so good. Right, baby steps. So we need that as a set of numbers. So what I'm going to do is let's just go in here and file.readAllLines, I believe, I need system.io to make that work. So file.readAllLines input.text should give us an array of strings. So then we can use link to say select for each of those. We are going to go s goes to int32. Oh, that's not right. I need system.link because that's not going to work. Thank you very much. So what I'm going to do, file.readAllLines, it reads that file and it gives back each line as a string in an array of strings. Oh, look, spam. God, the internet is a cesspit. All right. Hello, Naruto. Block user, bye-bye. And you can dick off as well, and you get in the bin. There you go. I know it's great because we've got this really good legislation from the EU about GDPR and not allowing cookies and all that kind of stuff. Surly dev, I'd mod you if I knew how to do that. Oh, I need 50 followers. All right, I'm just going to keep writing code and let the magic of the social network self-organize. That's what I'm going to do. Anyway, so /mod surly dev. This is probably not going to work. Cool. All right, it did work. I'm using Restream, so this is live on Facebook and YouTube and Twitch all at the same time, which is possibly a little bit ambitious for somebody with as much streaming experience as I currently have. But hey, fake it till you make it, right? Anyway, so file.readAllLines gets every line in a text file. We will take the encodings and nonsense as read for now, but it gives them back as strings. And if you add strings together, you get two strings joined together. We need to add two numbers because we need to find the numbers whose sum is 2020. So we need to say file.readAllLines, and then we're going to do a link.select. And for each of those strings s, we want to go int32. Now, we're going to skip validation because I've had a look at that input file. The input file, yeah, it came from a website, but everything in it I can see is a digit. And it's not random input that we're going to be getting from users while the thing's ongoing. So normally you do like an int32.tryparse, and if you get anything that's not an integer, you just discard it. I think this input is safe, and because I just downloaded it, I think it's not going to change. So we can just do int32.parse s, so that should give us a var ints equals big list of ints. Last line might fail. Well, let's try it. Let's do a console.writeLine ints. And then I'll do a console. Actually, I'll skip the console.read key. What I'll do is I'll just go in and I'll run .NET run this. Okay, so that it printed out nonsense because what it's given us is a select iterator, but it hasn't crashed yet. Actually, this is interesting. This is interesting because file.readAllLines.select isn't actually going to do anything. I need to put a .to list on the end of this to force it to actually run. Because otherwise it just goes, all right, here's the thing that if you come back to it later, we're going to enumerate and parse all of those integers for you. But if you just say file readAllLines.select, it doesn't actually do anything until we start pulling things out of that enumeration. Boom, there we go, system. Okay, so we've got a list of ints, so it's fine. Input's good, validation's good. Now we want to figure out the, let's have a look at the requirements, because why not? It might be important to get this thing right. Let's jump over here. So so it says the two entries, which is interesting. So it doesn't say the first two, so that suggests there are only two entries in this list that sum to 2020. This is fruity. So what we want to do is we want to start by looking. Okay, there may be a way to optimize this. The naive way of running this algorithm is we want to look at the first element in the list, and then we want to say, right, do any of the other elements in this list sum up to 2020? Then we want to look at the second element, and we want to say, do any of the elements after this sum with that one to 2020, third element? Now, we don't need to look backwards, because if A plus B equals 2020, we'd have found it when we looked at A. So we won't then need to, when we get to B, ask about A again. You see what I mean with this? Like every element, because addition is commutative, if we find the first one plus the second one, we don't then need to worry about second one plus the first one. So what we can do, this is probably easiest to do with a loop because, Let me do it with a loop. Then I'm going to see if we can clean it up a bit. And I equals naught. I is less than inst.length. This is where someone in the chat is going to go, oh no, .NET Core Framework 5, whatever, has a .advent of code solve day one method that you didn't know about. We'll see. So I has one inst.length. Doesn't have a length. It has count. Arrays have length. Actually, let's. Yeah, that'll do. So first equals ints I for int j equals I plus 1. J is less than ints.count j plus plus. So this is basically saying, all right, start at 0, 1, 2, 3, but when you're on 0, start at 1, ding, and then that one advance, and then this one start just after that and advance that one. So int I equals naught, int j equals naught, that's fine. Var second equals ints j. And at this point, if ints I plus ints j equals 2020, so at this point, we found our match. So we're just console.writeLine found it. Now, if I run this, what I'm expecting to see here is a single line that just says found it. So let's, I don't think I've got, what does F5 do in VS Code at the moment? .NET Core, yep, that's fine. That's fine, all right, fine, add, yeah, launcher.NET Core console app, that's fine, all right, run it, boom, let's see what we get. Yeah. All right, I'm going to fix this before tomorrow. For now, I'm just going to do good old-fashioned .NET run. So I'm expecting to see found it once, exactly once. Okay, that's good. It means there is a single pair of correct solutions in our data input. So there is VS Code. We want to know what those... Actually, we don't need to know what the solutions are. We just need to know what the product of them is. So ints I multiplied by ints j. Reason for this is if you look at what the Advent of Code brief is, multiplying them together produces the correct answer. Find the two entries that sum. What do you get if you multiply them? So that's what we need to put in there to get to the next step. So the sort of minimum viable solution here, we just need to know what the product of those two integers is. Ints I times int j. That's done, and at that point, we can just, yeah, we can just return, because we're in main, that'll do fine. Let's run it, see what we get. There we go, look at that, we got a number. So, let's see if that works. So Windows Terminal has Control-Shift-C and Control-Shift-V for copy and paste, which is not quite like normal copy paste. Submit. That is the right answer. We are 1 gold star closer. Woohoo! Amazing, winning at the internet. All right, let's push that lot to. Actually, let's just have a quick look at this. So there's two reasons to look back at code we've already done. One is, could we make it more obvious? The other one is, could we make it any faster? You know, there are optimization opportunities here. Highlight and single right-click in WinTerm to copy-paste. Let's try that. If I do that and right-click and then come over here, boom! Yes, you can! Thank you, Promofo. We learned something today. So let's jump back over here. Now, I'm sure that there could be some interesting optimizations here using, so there's a method in LINQ called skip, which will allow us to jump in halfway through a list and enumerate from that point forward in the list. But let's come back to it. Let's see what's in part 2. So let's continue to, actually I'll push that to GitHub, then we'll continue to part 2. So git commit -m. Well, so SollyDev says, it's annoying that Control-X-CV need the Shift key modifier. The whole ASCII thing kind of dibsed Control-C way back in like 1968 as an interrupt character for a mechanical teleprinter. And no operating system since has had the guts to use Control-C for something else when you're looking at anything that might once have been printed on a Unix terminal. So there you go. Right. Part 2. The elves in accounting are thankful for your help. One of them even offers you a starfish coin they had left over from a past vacation. They offer you a second one if you can find 3 numbers in your expense report that meet the same criteria. So, using the above example, the 3 entry. Okay, so there's a set of 3 numbers in here now, which will sum to give 2020, and we need the product of those 3. So we can use exactly the same algorithm. What we just need to do is put a third loop inside the second loop that's inside the first loop, I think, because again we don't need to backtrack. So if A plus B plus C equals 2020, then for any given A, we can look at all the B's, and for any of those B's, if we find a matching C, that's good, but we never need to look backwards. There's no risk that we're going to find a number and we're going to need to look earlier in our list of inputs. So I think, so that's day 1. So let's just split this out. I'm going to break these out into a couple of methods. So that one is class program. Static int solve part 1 list of int inputs. Okay, so the input's the same in both cases. We're going to read, but then we need to do something slightly different with the integer stuff. So if that equals that, return that. So that breaks that out into a method for us. Boom. There's that. Let's call that ints. Okay. Why is that complaining there? Because list int. Yes. A little weird quirk of .NET. Count is a property, but in some instances, count is also a method. And the generic list interface we've defined here is going to complain. That needs to be static. List could not. Yes, I need system collections generic. Now I can pull those back out. That will work. What are you complaining about? Solve part 1. Not all code paths return a value. All right. So if we get there and we haven't found anything, we could return 0. We could throw a new not implemented exception. Let's just return 0. That's probably the easiest option. It's not like we're going to be launching rockets with this thing or anything. So that's fine. And then so solve part 2. Is basically solve part 1. So I'm going to do some copy and paste, and then I'm going to see if what we can do to strip it down and make it more interesting. So static int solve part 2, see if we get the correct answer out of this. So int I, int j is less than that var second. And now you can probably guess what's going to come next. Int k equals j plus 1. K is less than ints.count k plus plus. And var third equals ints k. VS Code has some very interesting behavior where, in certain circumstances, if you type something, it thinks you want to wrap whatever's highlighted with the thing you just typed instead of over-typing it. So now, if ints j plus I plus j plus ints k equals 2020, return that times that times that. So there's all that lot. Solve part 2, that's fine, except that return statement needs to be out there. Right, let's see what we get off solve part 2. Console.writeLine, solve. Yeah, they are. Yeah, you're absolutely right. Good spot. Yeah. So Yeah, the comment, I've assigned first and second into a variable and then I've completely ignored them. So that can actually come out because we're not using it. And that can come out because we're not using it. And that can come out, and that can come out, and that can come out because we're not using it. This is why code review is important and why pair programming is good. So let's see, what do we get off solve part 3? Ints, there we go. Part 2, rather. My brain is really not firing on all cylinders today, but I asked them to delay the start of Advent till I was feeling better, and they said, no, it has to start in December because tradition, so here we are. Wire that back in. So main, ints, there, that's. All right, let's run that, see what we get. cd day1.net run, boom, there we go. Okay, so highlight, right click. That'll work. Let's try pasting that in there. That is the right answer. You have completed day 1. Woohoo! Look at that. Yay! And tweet the thing. Why not? Tweet everything. There we go. One-click social media engagement. Right, let's have a look at that code and see what we can do to make it a little neater and more elegant. Because we got a bunch of stuff in here that has been kind of replicated from one method to the other. And what would be nice, what would be interesting here would be a method. So something I often do when I'm playing around with code is I write the signature, or I write the function call I wish I could run, and then I work out what code I need to write to be able to run that function. So the scenario that I've got here, so for part 1, we needed to sum 2 numbers to give 2020. For part 2, we needed to sum 3 numbers to give 2020. And so, hey Luce, how you doing? So what I'd like to be able to do is, I've got this list of inputs here. That's all looking pretty good. So I'd like to be able to say var solution equals solve, which doesn't exist yet. And I'm going to say, here's my inputs. This is how many of them I want to count up. And this is the sum that I'm looking for. Let's make that a little bit more explicit here. So var how many ints to sum equals 2 var, what is it, the thing we want, the so let's say how many ints to sum, and we want that to the required sum. We could call that target, I guess. Naming things is hard, way harder than writing code. And then console.writeLine solution. So that's the method that we want. So you can heckle. One of the best ways of learning anything is to go on the internet and tell them what you think the answer is. Because if you go on the internet and say, how do I do this? People just be like, busy, can't be bothered. But if you go on there and say something like, I'm going to build a DOM diffing algorithm, you get loads of people going, no, you do this instead. What are you simple? Cunningham's law, the best way to get a right answer is to share the wrong one and wait for people to correct you. So it's entirely possible that by the end of this, I am going to have learned more .NET than I have in years, just from people watching the stream and going, that's not how we do it anymore. Maybe some Rockstar later in the thing, Chris. Maybe. Actually, if we got a bit of time, I've nominally put in an hour a day to do this. Some of the Advent of Code things are easier than others. This one, we got the 2 right answers already. Took about half an hour, or 25 minutes to solve it. Maybe we could have a go at doing this one in Rockstar at the end. But first, I want to sort of simplify this a bit. So we've got this method now that I want to write. I want to write a method called solve, and solve is going to take a list of integer, which is the integers that I'm summing. It's going to take an int, which is how many ints to sum, and it's going to take an int, which is the required sum. So this is where we need to stop and think for a little bit, because I think we can probably, this is kind of, it smells like recursion. It smells like something we could do recursively, because in each instance, what we want to do is, if we've got a particular number, we want to see, does anything in the rest of our input? We've got a scenario here where we've got kind of like a head and a tail thing. We've got this number and we've got the rest of the list. And if this number plus anything in the rest of that list adds up to a particular sum, then we found our two solutions. We want to know what it is. We are headed for recursion. If you don't know what recursion is, see recursion. So what I think we want to do here is let's say var head equals, here we go. You can tell it's getting a little bit lispy here because I'm about to use a head and a tail on something. Var head equals ints.first. So we got, that's the first one. Var tail equals ints.skip. That's the rest of them. Now, in this instance, what we want to do is say if, well, what's going to be the escape case here? So if so so we've got a list of things. The sum of required, sum of selected elements is the required sum. So yeah, but what are the selected elements here? That's the thing we need to ascertain. What is the base case in our recursion? So I think so. The recursive case is going to be, all right, let's knock the head off the required sum and see what, yeah, tail, no, because tail is still going to be a list. So there could be a scenario where yeah, so one of the things about recursion, I always think like building recursive algorithms is a little bit like building an arch. It's like it doesn't make any sense until suddenly it clicks and then the whole thing fits in. It's base case equals if how many ints to sum equals 2, then exactly match on required sum in list. So what we want to look at here is that's all we need to do. So the scenario, okay, let's start with the noddy case. Let's start with the simplest possible case we got here is actually how many ints to sum is 1 and the required sum is 2. If we only got one input, then what we need to do is find that number in the list, right? And then if we got 2 inputs, we need to look at the first one and see what's in the second one. If tail is the empty list, return. Otherwise, try adding the head to the accumulated total and check against the total. So I think instead of adding an accumulator on the total, what we want to do is decrement the required sum by the current value of head. So let's look at head. So if head equals required sum, return head. Otherwise, we want to return solve, and at this case it will be, so ints.skip1, so ignore the first one. How many ints to sum is going to be the same? We're kind of ignoring that for now. This is no. The how many ints to sum. So there's a guard clause in here. If we're looking for 3, but we find 1 plus 2 equals 2020, that's not right. It's not strictly recursive. This thing needs to decrement by 1. So if the head is the required sum and the how many ints to sum equals 1, return the head. Otherwise, return solve. So let's see what we've got here. Let me just give us a little bit more space. Return ints.skip1. How many ints to sum? This is the most confused, or rather the most stuck I've ever been on a live stream, but we'll figure it out. So that's fine, that's fine, that's fine, that's fine, that's fine, that's fine. So that's, let me just see what happens with this. I'm going to try this on and see how it fits. Okay, so inst.skip is going to complain there because skip returns, so that actually needs to be an IEnumerable of int. That should give us a solution. So that's fine, that's fine, that's fine, that's fine. There we go, and I'm going to run that, see what it does, because it might fail in a way that is enlightening. Whee! That is definitely enlightening. What's at the top of that stack? I don't know what happened there. Sequence contains no elements. I know why that's happened. That's happened because we've knocked things off the stack. That needs to be first or default, and if head equals default int, then we want to return, well, that's our blew up. That's our you didn't find any numbers case. Throw new exception. Under what circumstances in .NET VS Code, I have a question for you. Is it more likely that I need a new style URI parser than that I want to create a new something? Like, seriously, where do they get these hints from? Right, let's try that. Boom. Of course, but that's not going to be at the top of the stack. So let's put a try that lot and ints equals that console.writeLine that catch exception ex and console.error.writeLine ex.message. There we go. And this is the point where you should put a logging framework in, but we'll come back to that for another day. .NET run that. No, .NET earn is not the correct thing. .NET run that. Thank you. You ever get the thing where one of your hands moves a little bit faster than the other? Ooh. Run out of inputs. Okay, that's cool. So that's because the number 2020 doesn't appear in our inputs anywhere. So let's have a look. Let's pick something that does. 1934 is a very good year. Let's try that one. So there's our program.cs. Let's see what we get with 1934. Run out of inputs. Interesting. Why did that not work? So it's because this number here, yeah, you want the minus head at the end. Is that the case where the head didn't match? So So we have a scenario here where if the head doesn't match, so if we find the number we're looking for, yep, we want to return. So the accumulator here actually needs to be a multiplier. Last time, -1 on the middle parameter or the minus head on the last one. Yeah. So the how many ints to sum is right. Let me think about this for a second. So if the head equals the required sum, you have to decrement and yeah, we do, but we kind of don't, because we only want to do that when we find a solution. We don't want to do it on every case. So if the head is the required sum, yeah. The return statement logic only applies only if how many ints to sum equals 1. I knew we'd get to 40 minutes and someone would say try functional instead of recursion. But I'm fascinated by recursion now because recursion should be possible. We have already solved it, of course. You know, the product is shipped. The client is happy at this point. The solution has been implemented. But I'm trying to figure out what we need to do to make this thing. So the head is that, and if the head is the correct answer, so if the head is, base cases here are we've got enough. Right, wait a second. That's fine. Yeah, finding no matches will be a normal case. Yeah. Well, actually, if that one, we want to return 1, because at some point we're going to need to multiply what we've got in our accumulator by the... because, yeah, we want to multiply this match by that match by the next match, correct? So we need to be able to say, let me just shrink this down a little bit. I've got huge chat from the days when I was at the far end of the room doing this kind of thing. There we go. That's better. So, right, the base case is we give it a required sum, and if we find that, we return it, and if we don't, then... Yeah, the aim is to return the product. So let's yeah, we need to add them at some point. So what we need to do is to decrement the required sum. So first case scenario, find us this number, and if you find it, return the product of this and the rest of the list. Yeah, that's that. Okay, this is what I think we need. If you find the number you're looking for, then you want to return that multiplied by the solve of... Yeah, this is it. So head equals that. Ints.skip 1. So if we find the number we're looking for, return that number multiplied by the solution of that. How many ints to sum minus 1, and required sum minus head, I think. That's definitely, or that's probably the syntax we want on the kind of the accumulation, the recursive case. So if... Yeah. No. Yeah. No. That is the case when the list is empty inside the upper if. So yeah, it is. If head equals default int. So that's if the list is empty. Actually, we could do that with if ints dot any. So if there aren't any ints, return... No, if there aren't any ints, it's gone wrong. We're not going to hit the end of the list. If there is a solution that exists, we should never get to the end of that list. So at this point, we should be able to throw new exception. Because in every other case, at some point, the required sum that we are now looking for will be found. If it's a valid scenario, if it's a case that we can actually find, then the required sum that we are looking at is going to occur inside the what we've got somewhere. Yeah? So if we hit the end of the list, it means we're looking for something that's not there. So that is always going to be an exceptional case. Throw new exception, no matches found. Boom. So that's going to blow up. Yeah, Chris, you will if you pick two numbers for which there isn't a third. But in that case, yeah, I see what you mean. Oh, this is fruity. Yeah, because we may have started with the wrong two numbers. Yeah. So if that, so what the hell do we return? How do we? What are the different return cases we got out of this? Right. So yeah, it is. So we need to. So it's a recursive search. So what we need to do is look at base case. What do we do if we look for a single integer and we do not find it anywhere in our list? And at that point, we probably want to return. What do we do if we return 0? So if we run out of stuff, we return 0. There's nothing left. Inst equals first.default, and then if head equals required sum, return head, else return solve inst.skip. 1, how many inst to sum will be the same, and required sum will be the same. So this, what we got here, this should work for finding a single integer in a list of integers. So we should get back, if it's in the list, it'll return the number we asked for. If it's not in the list, it'll return 0. Let me see what this does when we kick this thing off. Why is that complaining? Because I'm missing a thing on there. So let's .NET run that. Okay, so that's finding 1934. If I change that number to something I know isn't in the input, that might be a bit big for an int32. Let's run that again. 0. All right, so that'll give us a number if it exists, and it'll give us 0 if it doesn't. So now what we got to do is say, all right, so for a given head, if we subtract that head from the required sum, can we solve the equation using what's left in the list? So if head is the required sum, try this. What happens if we so that's going to knock that one off. So, right, let's imagine we got a list of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we are looking for 3 integers that multiply to, or that sum. 3 integers that sum to give, say, 8 plus 16. So exactly 3. Are there multiple ways of getting 16 out of that set of integers? Yeah, there are. There's 2 plus 6 plus 8. Okay, so the input actually has some constraints on it, because there can't be multiple solutions that sum to give the same thing. This is fascinating. All right. We got 12 more minutes. I said I wasn't going to spend more than an hour on this. If we can get it working recursively in 12 minutes, we got it recursively. If not, hey, never mind. It was good fun. So let's say if inst.any returns 0, if not, then if we need a what's 24, Keith? Where do I want to use 24? Yeah. Even the first head you may find may not be part of the numbers you are looking for is exactly right. So we've got a lot of scenarios where if 7 plus 8 plus 9, yeah, you're right, yeah, 24. Okay, so at this point, if the head is 1, then the tail is going to be look for 23 in 2, 3, 4, 5, 6, 7, 8, 9. At which point our recursive case is going to say the head is now 2, which is saying look for 20. So at this point, it'll be 23 minus 2 in 3, 4, 5, 6, 7, 8, 9, at which point the head in our next recursive case is going to be 3, and we are looking for 23 minus 3, 20 minus 3. Okay, so the integer to... yeah. All right, so the how many ints to sum, that's important. We need to decrement that every time we recurse, because that's the thing that says this did not result in anything. This is you didn't find anything in this enumeration. So at that point, we need to say if yes, this is surprisingly complicated to do with recursion. And easy to do with loops. Hang on. Right. So I think the yeah. So if you're trying to how many ints to sum equals 1? Well, actually, what we want is if I think how many ints to sum is the thing that needs to be decremented every time. So if let's try this, how many ints to sum equals 0? Then this is our bailout case. This is you need to stop doing stuff now. That's so at this point we return 0. There may be a way. So I think that's the slight complexity that we got going on in here is that a solve can either succeed or fail, and if it succeeds, it'll give us back a number which is a product, but if it fails, it should give us back something that indicates we didn't find anything. There we go. Okay, I think we're onto something with this one. So if how many ints to sum is 0, or if we have run out of numbers to search, then return 0. Yep. Otherwise, if yep. I think we got two different bailout. Yeah, the product will be 0, but then I need to be able to check whether the product of a kind of, it's kind of like a depth first search thing. As in, for this input, you need to then go all the way to the end on all the different possibilities, and if any of them return the right solution, then you found it. But if they don't, you've got to go all the way back up to kind of the root of the tree, and then recurse down a different branch from there, and then all the way back up. So I think we've got the edge cases we've got here are if the head equals, so if how many is to sum is 0, or we've run out of ints, we return 0, that's fine. If how many, so var head equals ints.first, that's the first one. So if how many ints to sum equals 1, because we only want to return if we got to the point where we're only looking for one more number, right? If we're looking for two numbers, we can't return anything because we don't know if there's another number left in the list to go with the one we just found. So if how many ints to sum equals 1 and head equals the required sum, return head. Otherwise, we want to return head multiplied by solve on ints dot. What? No, come on, ints dot skip 1. How many ints to sum minus 1 and required sum minus head. So see what that does. I think there is possibly a case in here where, yeah, we probably could do it entirely with link, Nick. First, you got to figure out how to solve it. Then you got to figure out how to solve it using link. Okay, so that's returning 0. That's interesting. So at that point, hang on. So basically there, yeah, if anything, if we get to a 0, then it means we're going down a dead end. We need to backtrack and we need to try again. So we need to see what that does. Yes, I do. So the font is a thing called it's called Fira Code. It's here. And it's brilliant. And it does stuff like if you're in VS Code, so double equals goes to one of those, triple equals goes to 3 lines like that, and it's got stuff like not equal to, and if you're using like F# with pipe operators, it turns them into little triangles, and it's really cool, and it's awesome, and you should check it out. Use a thing called ligatures, which if you're into typography and type nodes and stuff, then that is kind of fun. I'm genuinely wondering whether it's possible to do this with recursion, and it should be, because it's a depth-first search kind of thing. Yeah, map the solve function over the tail, filter the zeros out, and return the one number that's left. So Maybe there's a much easier way of doing this generically, which doesn't involve recursion. That equals that, that equals that, that equals that. Yes. Yes, 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 yes. Return solve ints dot skip one. Actually, let's do a nice var tail equals ints dot skip one. So tail, how many ints to sum required sum. Let's see if that does it. All right, so that's 1934. Off ints to sum is 1 and required sum equals that. So if we plug in 2 and 2020, what do we got? Oh, look at that. Magic. Thank you, Cinciat. You're absolutely right. So our base case here, if we... So yeah, what was... what was missing is that if the number we're looking at doesn't give us any solutions at all, what we need to do is then restart kind of the whole solve algorithm with the same ints to sum and the same required sum, but now we need to start at the second element in the list, because it could be that the answer is the last three things in the input. So yeah, that's what we need. Is the base case is, so if we run out of anything, run out of inputs, we return 0. That's our this is a dead end flag. And then for each element, if this one solves the puzzle, we give it back, and that then multiplies it by the next one on the stack, which multiplies it by the next one on the stack, which gives us back the product. Otherwise, if what we need to do is to ignore the one we're on and move on and look at the whole rest of the puzzle. So let's just check that works. 3, 2020. Let's see what we get. Yep. Which I think that was definitely the answer to part 1, and that one I'm pretty sure was the answer to part 2. Let's punch that in and see whether it gives us the right thing. Yeah, that should be fine. Submit that. Ooh. Oh, I already completed it. Yes. Return to day 1. Yeah, that's fine. Both parts are complete. Yeah. Yep. 257778836. 257778836. That was fun. Thank you, gang. And we're 2 minutes past 5, so it took like a fraction over an hour. And I wouldn't have got there without your help, so thank you very much for that. But there we go. We got solutions to both parts of day 1, and then got this wonderful, reusable, recursive, beautiful, solvable solution. So let me just put a naive solution using for loops for part 1. Naive solution using for loops for part. That's part 1. That's part 2, isn't it? And that's a for finding the product of a set of integers in a list that add up to a given sum. Boom. Hooray! I am wondering if we can do it with link. But anyway, that's all for today. I'll see you all tomorrow for day 2. So there's apparently a thing you can do in Twitch where you send all the people who are watching to somewhere else, but I have no idea how that works. I'll research that later. Thank you, gang. That was a lot of fun. I'm out of here.